In this video, we'll be looking at how to solve exponential equations using logarithms. So an exponential equation is something like y equals e to the x. So it's something where the exponent is the variable. E in this case is Euler's number. It's a number kind of like pi. It's like 2.719 something. It's just a number or a letter that we use to represent a number that has an infinitely repeating decimal. So what we want to be able to do is solve equations that are something like 4 equals e to the x. So what would x be in this case? Now, to be able to do this, we will be using logarithms. And the reason why we use logarithms is because those are the inverse functions of e. So, for example, an example of using an inverse function is, let's say we had the square root of 7. Now, I don't know what the square root of 7 is off the top of my head, and you probably don't either. We would need a calculator to evaluate that. But the square root of 7 squared is just 7. So those two things kind of undo one another. The square root and the square just kind of undo one another, and we get 7. So the idea of exponential equations and logarithmic equations is the same. So if we looked at a graph of y equals e to the x, that's an exponential equation. And then if we look at the graph of natural log of x, y equals natural log of x, that is its inverse function. And so we can see that it kind of mirrors itself along this diagonal line here, and that's what inverse functions do. So to solve this exponential equation, 4 equals e to the x, what we'll do is we'll take the natural log of both sides. So natural log of 4 equals natural log of e to the x. Since natural log and e are inverse functions of one another, they kind of undo one another. And so we would get the natural log of 4 equals x. So there's going to be some other examples that you'll see. One of the things that you'll notice that I did here was that I used parentheses anytime I took the natural log. There's an example in our orientation homework where you end up, if you don't use parentheses, you end up with something like natural log of x plus 2. And so what a common mistake that I see students make is to not know where the parentheses go here. So when it comes time to evaluate it, they just kind of put the parentheses wherever, and that doesn't work out super well. So this is actually equivalent to the natural log of x plus 2, whereas it is not equal to the natural log of x plus 2. So we don't want to do it that way. So anytime you take the natural log, make sure to put parentheses around the thing you're taking the natural log of. Otherwise, you might mess up your order of operations.